In this next section, we're going to look at a physics application, that is hydrostatic pressure and force. We need to talk about some physics formulas and constants that we'll be using in this section. The idea here is that we have a plate or something submerged underwater, and as you see in this little drawing on the right here, d meters underwater, and the plate is kind of perpendicular. The line is perpendicular to the plate, or the plate is parallel to the surface of the water here. Okay, so some formulas. From before, we have force equals mass times acceleration, in this case acceleration due to gravity. But the mass that we're thinking of here is the mass of the water above the plate. So the mass is equal to the volume of the water times the water density. And you can think of that as we've got a column of water above this plate. So the area of the plate times the depth below the water would give us the volume times the water density rho. So substituting that back into our force equation, we have force is equal to the area times the depth times the water density times the acceleration due to gravity. Also, the pressure is equal to the force divided by the area. So the pressure is equal to the density times the acceleration due to gravity times the depth. Or if we rearrange this, the force is equal to the pressure times the area. This is the main equation that we're going to use. We're going to try to find the force by looking at strips, horizontal strips underneath the water, where they have where we'll find the pressure and the area, and then we'll use an integral to sum up these small force strips. Okay, so for some constants that we'll need, acceleration due to gravity is 9.8 meters per second squared. Density for water is 1,000 kilograms per meter cubed. And then in our units here, in pounds and feet, we use delta, and that is 62.5 pounds per cubic foot.